Space, the final frontier. This is the Observer's Notebook, the official podcast of the Association of Lunar and Planetary Observers. Its mission to explore the solar system, to seek out new observations and data, to boldly go where no podcast has gone before. And now the host of the Observer's Notebook, Tim Robertson.
Hello and welcome to episode 224 of the Observer's Notebook, the official podcast of the Association of Lunar and Planetary Observers. I'm Tim Robertson, your host. I want to thank you for joining us. A special welcome goes out to all of our brand new listeners. Thanks for finding us. Hope you enjoy the show and be part of our growing community. This podcast is made possible by support from our listeners. If you'd like to help keep the podcast going, you can join us on Patreon for as little as $1 a month. For $5, you receive early access before it goes public. For a monthly donation of $10, you receive a copy of the Novice Observer's Handbook. And for $35 a month, you'll be recognized as the producer of this podcast. You can find out more at www.patreon.com/observersnotebook. And to learn more about the ALPO, visit our website at www.alpo-astronomy.org, where you can join the organization, and membership begins on only $22 a year. Now let's dive into episode 224 of the Observer's Notebook podcast. Enjoy. All right, I'd like to welcome everybody back to this edition of the Observer's Notebook podcast. And we're going to talk a remote planet, Uranus. And because we have that planet, we are talking to the coordinator for that section of the ALPO, Richard Schmude. Welcome back, Richard.
Thank you, Tim.
Yeah, now before we get into it, can you start by telling us a little bit about the Uranus section and what goals are and what kind of observations you collect?
Okay, well, the Uranus section, I was appointed coordinator back in November of 1990. And when I got the appointment, the first thing that ran through my mind was, I need to fork out some money and get a photometer. Uranus and Neptune are very, very far away, and their disks are very, very small. And so I pretty much reasoned pretty quickly, the biggest way I can make contributions is with photometry. Now, I do believe that with a 20-inch telescope and with first-rate image processing, you can do some good work there. But so anyway, I have been doing photoelectric photometry since 1991 with Uranus and Neptune.
Okay.
And what I do is I measure the brightness of Uranus and Neptune in green, red, blue, and infrared filters, and recently in ultraviolet light. This can give us an idea of color and color changes on Uranus.
Okay. Like you mentioned, Uranus is often overlooked. What drew you to observing this planet?
Well, it's just that it is overlooked. Everyone talks about Mars. There's a ton of stuff on Mars. I sometimes like to be the one that's a little unique. And
that you are.
Yes. So I guess I'm a unique person. I'm not one of these that follows the crowd oftentimes.
Okay.
So and then I found a niche. I back in 1990, 91, I was working at Los Alamos as a graduate research assistant.
Okay.
And photoelectric photometry, not a lot of people were doing planets. Now, there's a lot of variable star work, but again, they're dealing with fainter objects. Planets, generally, they can go to -4 or brighter magnitude for Venus. And so I reasoned, I can do photoelectric photometry of Uranus. And since I was young, when I got the appointment, I was 32 years old. So
Okay.
and I'm 67 now. So You can do the math, 35 years roughly, or 34 years I've been able to study. And you do need to be young to to study some of the trends on Uranus because, one season on Uranus is 21 years long.
There you go. Yeah. So for amateurs that want to observe Uranus, what are some of the main challenges that they face?
The big challenge is you need to find it.
Okay.
What I say, and I've said it in my book, I wrote a book on Uranus,
Mhm.
Neptune. Use binoculars. Use binoculars. Find Uranus and Neptune in binoculars. And then find it in your finder scope, and then find it in your telescope, low magnification. Then you can up the magnification. Now, of course, if you have a go-to telescope, you still need to know you need to go to good star atlas. It goes down to about magnitude 8. The Millennium Star Atlas is very good.
Hmm.
Use low power. In other words, you go to scope, just make sure that you got it there. That's the thing. It's great. Go-to telescopes are great, but it doesn't mean it's pointed at Uranus.
Hmm.
You have to level the telescope. There's undoubtedly other things you have to be aware of. So you'd still need to confirm, yes, I've got Uranus there. So you need a star atlas, a red flashlight, a red light flashlight, and then you can confirm, hey, that little dot there is Uranus.
Yeah.
And again,
What?
it's fairly bright.
Yeah. So what size telescope and magnification do you recommend to clearly identify the disk of Uranus?
Okay, my feeling is you need about an 8-inch telescope.
Okay.
You need at least good seeing, not excellent. You can do good, but of course, excellent would be better. Um, Magnification, well, of course, you need low magnification just to say, yes, Uranus is in the field. I see the dot, Uranus is. Crank the magnification up to about 150 to 200 power.
Okay.
You should be able to see a little disk. Now, Neptune, that's different. You need good to excellent seeing to confirm Neptune. Neptune, believe it or not, is actually a lot harder to confirm than Uranus.
Yeah. Okay. Now, with the other gas giants, Jupiter and Saturn, and with Mars, you can see details on the planet relatively easily through a
Yes.
telescope. Are there particular filters that help bring out details when looking at Uranus?
Um, Yes, I would use a red filter. Now, our eyes can detect red light. I talk a little bit about this in my Uranus book. I believe Rich Jekyll in the greater Atlanta area did make a drawing. I believe did use a red filter, and
Okay.
he could see a bright sort of um, north polar hood, or maybe a south polar hood at that time. Um, And one person who actually succeeded in seeing and drawing the North Polar area was Patrick Moore, the late Patrick
Hmm.
Moore. And he drew Uranus way back January 13th, 1954. I don't know if I can share, I've got a picture that I can show the audience. I don't know if you can,
Okay, well, I can see that.
uh, yeah, if you can.
Yep.
Yeah, okay. And there's just sort of a brightening there, and then it's dark everywhere else. And Patrick Moore, I'm sure, was a first-rate observer. He's got it in his guide. It's called Guide to the Planets. It's a classic book, probably written around 1960. And so I really commend Patrick Moore on that. He really drew, I believe, the North Polar Hood, what, 70 plus years ago.
Hmm. So when during this year is Uranus best placed for observation, and how high will it get from, let's say, mid northern latitudes?
Okay, let's say 45 degrees north. It's going to
Okay.
get 50 degrees above. Wait a minute, let me see. I think it's going to get closer to 60 degrees above the horizon.
Okay.
And again, depends. Are you a late night person, early morning? Do you love observing in the cold, or would you rather not observe in the cold? All those are important variables.
Right.
I live in Georgia, so October for me is a beautiful time. We get nice clear air. It's not too terribly cold, but you go up to say Iowa.
Hmm.
Iowa's a lot colder, and I would lean towards again, you're going to have to sacrifice somewhere.
Hmm.
Either going to have to get up early in the morning or put up with the cold. And each person is different on that, but I would say Iowa, if you can get clear days in November, that might be a little better. And again, it'll get up to see Uranus's declination is now 20 degrees north, which means it'll get quite high in the sky.
Right.
Even for Iowa, it will be above 60 degrees when it crosses the meridian.
Okay. Now, visually, Uranus shows a pale bluish disk,
Yes.
but amateurs have reported seeing banding and brightening near the poles, right? And you were talking about that earlier.
Um, yes, I know EM and the Tenouti saw banding. I'm wondering about that. But let's go back to something else you said. You mentioned the color.
Hmm.
Uranus's color is changing.
It is.
Yes. What's happened is, you see, back in 2007, the equator was facing the Earth. Uranus's equator is facing the Earth. Today, the North Polar, we'll call it a North Polar hood, is facing the Earth. It is quite a bit redder. Now, still blue planet, don't get me
Mhm.
wrong, but it's not going to be as blue as what it was, say, in 2007, 18 years ago or so.
Interesting.
And this is what I have measured with my photometer. Of course, a professional astronomer out in Arizona has also recorded images of the South Polar hood back in the 1980s and 1990s. And he actually reported in the professional journal Icarus.
Hmm.
And so I'm getting a sort of quantitative measurement, if you will, of the color of Uranus. And it's quite a bit different today than what it was, say, in early about 2007, 2010.
Okay.
This is what's exciting. I'm excited. I'm
Hmm.
as excited today as what I was when I took over the position of coordinator of the
Hmm.
remote planet section. I mean, I'm still learning today. I'm 67. Now, of course, I've had to collect data every year.
Right.
I kept track of that, published it in the journal, which I commend you all for. And so now I have a fighting chance of understanding some seasonal changes on Uranus. I mean,
Mm.
Mars, I mean, what, 8 months and you got a new season, or if
Right.
that?
Yeah. True.
Uranus, you got to have to wait decades.
Now, do you do imaging of the planet as well?
No,
Okay.
no, I let others do that. Imaging has got its own um, issues. The first one is you need a big telescope.
Mhm.
I've got too many trees in my yard to have an observatory. The trees are
Well,
just,
there's remedies for that. There's a saw.
yeah, there's a saw, but I'm kind of I gotta admit it, I'm probably a tree hugger.
Oh, okay. There's nothing wrong with that. All right.
That's sort of my personality.
Yeah.
So
So, how are the ALPO members contributing imaging data and photometric data for professional studies?
okay, we've got a variety of people. We've got over the years, Jim Fox was
Mhm.
just terrific. Submitted terrific photometric data, but in the blue and V filter. Now, not the red or the infrared. I've been doing, well, I started doing ultraviolet work about 11 years ago, 10 or 11 years ago.
Okay.
Others have submitted images. There's a guy over in Italy. I don't want to say his name because I'm going to probably mispronounce it. Doing terrific work.
Okay.
Um, Others have done great work. I think Don Parker did, the late Don Parker did, Damian Peach.
Mm-hmm.
I believe Clyde Foster has done some good work too.
Mm-hmm.
Um, and then the third area, and this is very recent, and this I think has great potential, and that is Rick Hale using a small telescope. I'm talking about 4 inches in diameter, getting images of 19th magnitude objects from his backyard.
Wow.
Now, with a little bit of calibration, he can get photometric data of Pluto with a 4 inch telescope.
That's
That's what I believe. But again, there's a little bit of, and again, Rick knows the technical
mhm.
aspects. He's a professional astronomer. He was a
Yes,
former
yes.
professional astronomer, and you have to calibrate your equipment to the standard system. Now, of course, there might be some difficulties there because you don't know what filters they've got built into these telescopes. But I think the day is coming when we're going to be able to get photometric data of Pluto with a telescope and just carry in your hand.
Yeah, these smart telescopes that are out there now, I mean, they lend themselves to doing photometry too.
Yes, and this is one thing we have to keep in mind. The ALPO is a general rule. Equipment's changing. It's not just sitting out in the backyard looking through a telescope anymore. I mean, still, I think that's still important. And of course, the meteor section, that's primarily what they do. But a lot of it now is you've got instruments, you got cameras and photometers, and who knows what else. There's probably some good equipment over in Europe.
Hmm.
They have this one person in Germany, I believe he had sort of a handheld photometer.
Hmm.
So anyway,
So, what about occultations of Uranus and its moons? Is that something that we do or we have done?
yes, yes. Roger Venable, who is, I
Hmm.
believe, he is the president of IOTA now, International Occultation Timing
Yep.
Association.
I'm going to have him on the podcast to talk about IOTA very soon too.
Yes, he actually attempted Uranus, and I think he did get some Uranus occultation
Oh,
data.
wow.
So again, that's very specialized work. Generally, you need a big telescope. Well, I take that back. If you're doing Pluto occultation, you probably do, but you need dark skies that helps out. Of course, a very good time signal, and of course, you need lots of memory on your computer because you're
Hmm.
saving a lot of files. And so Roger's done good work. I think he had the most recent one was he reported a negative observation, which means he didn't observe anything. But again, that's still
That's
data.
important. Yeah.
It's important, yes. And then,
Okay.
of course, there's the whole issue of rings.
Mm.
People have now been able to image rings. I'm talking about amateurs with, 10 to 14-inch telescopes. I've
Wow.
received images just this year showing the rings.
Wow. Is the Uranus section fairly active? Do you have a consistent list of observers that contribute every year?
Yes, I would say, fairly active. I have some that come and go,
Okay.
some retired. But yes, we've got a core of probably 6 to 8, and then of course we get some others that come along, come and go,
Hmm.
and so it's all good. Yeah, I've just this probably 2 months ago of that, I received a couple of images. In fact, I just received an image this week showing the rings.
Wow.
We're getting the
Fantastic.
rings of Uranus.
Yeah. So observers that are listening to this podcast or watching this podcast that want to submit data, what kind of reports do you accept? Do you accept sketches, images, photometric image measurements?
All,
What type of
all of
things?
it.
All of it.
Now with this drawings, images, sketches, the basic information is needed. I need to know the telescope size and type, your location, your name, filters. Filters are extremely important, and it can be tricky. Filters can have leaks. And when I say a leak, I mean light getting in that's not supposed to get in. For example, if you've got a blue filter But if it transmits near infrared light, you're not going to get a blue image.
Okay.
You get something that's combination of blue light and near infrared light. So again, filters, you have to be careful. Make sure you've got an infrared blocking filter.
Okay.
Um,
So when people send you their observations, what happens then?
okay, what happens then is that I look at them. They are archived, but I'm not the one that's archiving. I believe that our webmaster's doing that.
Hmm.
Um,
But
yeah, it's a very,
you use them for reference in your operation reports, though.
yes,
Yeah.
yes. Everyone who submits something to me, I acknowledge. If it's drawings or images, usually it's images. Most people submit images. Jim Fox, however, submitted photoelectric data. That was really good. I really
Mm.
appreciate that. He probably submitted 300 or 400 observations, and I really think he's deserving of the Walter Haas Award.
Okay, we'll put his name in next year.
Yeah,
But don't tell him.
yeah. I'm pulling for him. He his data was first rate.
Okay.
Did first rate work. And unfortunately, though, he had some bad luck. I think he had a lightning strike near him and it damaged his equipment.
Oh my.
Yeah.
I hadn't heard that. Wow.
Yes.
So how can observers stay updated on Uranus related alerts and activities? Do you have anything on the from the ALPO that you put out?
Really, I don't. I used to put out a newsletter. Um, but today you've got the computer. The computer is
Mhm.
a whole lot different than what it was, say, in 1995. I mean,
Yeah. And our
you,
website also has alerts for things like that as well, too.
yes, website is good. And then, of course, you can get finder charts on, you just type in finder chart Uranus 2026, let's say, and it just pops up as beautiful finder chart.
Okay.
I just go there and print it off every year. So, I don't need to send out finder charts anymore. I mean, it's better, it's just better there. Just computer is just a wonder.
Yeah, yeah. So what are some goals or upcoming projects for the Uranus section that you might have?
Okay, goals. First off, we need to continue monitoring the North Polar Hood, we'll call it, a big bright area. One reason why is because in my most recent report, there was actually sort of a large fuzzy gray area in the North Polar Hood. Is that the beginnings of it fading?
Hmm.
Um, I don't know. Is it an artifact? Perhaps. But again, we need to monitor this, get images. I use a little software package called WinJupos
Hmm.
to measure the latitude of the edge of the North Polar Hood. And it's around 45 degrees north right now.
Okay.
And so imaging is very important. And so the goal is to monitor the North Polar Hood. A second goal and a goal I'm really excited about. Let's get some color measurements of Uranus this year and through the early 2030s because will be the North Pole is going to be facing very close to the Earth in 2029, 2030, but it's already getting very close now.
Okay. All right.
And so I want to put together a record, a color record, if you will, of Uranus going all the way back to the early 1990s,
Okay.
showing how the South Polar Hood and now the North Polar Hood is affecting the brightness and, more importantly, the color of Uranus.
Okay. Are there future space missions to Uranus planned right now?
There is talk of a Uranus spacecraft. I believe it is NASA. The Europeans also were talking about it, and I don't know if that is solidified or not. I know they were proposing it. I actually responded to that, saying that'd be great. I mean, one of the things I feel we need to learn more about Uranus and especially Neptune. Neptune's density is quite a bit higher than Uranus's. Now,
Mm.
I'm talking about 20 to 30% higher.
Wow.
Could
What?
Neptune?
Why is that?
Well, that's a good question. We've only sent one flyby past the two planets with, let's just face it, early 1970s technology, if that.
Okay.
Um, it's now 2025. Just think what we can do now.
True.
One of the things I've always wondered about, they call Neptune a gas giant. Could it really be more of an ice giant with just an atmosphere?
Mm.
I don't know.
True.
But if we need to learn more about it, and that can be done through gravity measurements on a spacecraft, perhaps radio, and using the different wavelengths of light to study Neptune, because Neptune, I really feel, is quite a bit different than Uranus.
Mm. Interesting. They look similar. That's the interesting thing.
They look similar, they're nearly the same size, but the density is 20% or more greater for
Wow.
Neptune.
Did not know that.
Yes.
So if there's a beginner out there that's never tried to look at Uranus, what advice or encouragement would you give them to start?
Okay, well, one thing they can do sort of quickly is get a good pair of binoculars
Hmm.
and just do visual magnitude estimates of Uranus. They can do that. They'll learn how to find the planet. I still am collecting that. I've just estimated the brightness this morning of Uranus.
Mm.
And the reason why is going back to the late 1800s. You can see Uranus is a little brighter when its pole is facing the Earth and when its equator is facing the Earth.
Okay.
And I talk about this in my uh, Uranus book that I published with Springer back in 2008.
I'll put a link for that in the show notes too.
Yeah, that would be great. Yeah,
Okay.
please, because that's still a very good book. A lot of good information there.
So you're up this morning looking at Uranus, doing how did you give me your process for doing that?
Okay, well, first off, this morning I just woke up. I wake up several times in the night, looked at the clock, said, "Oh, it's 4:30 or whatever." I think I can do some measurements. And of course, it was bright or it was dark sky,
Hmm.
no very little moon, clear. And I said, "Okay, I'm going to go out there because I want to get at least 10 red filter measurements, because 10 is better than, I like to get at least 10, if not more."
Hmm.
And so what I do is turn the photometer on, check the sky to make sure I don't have clouds. If I have clouds, forget it.
Hmm.
But it's clear, so I let the photometer warm up for 15 minutes. I just set up my mount. I've got a table, I've got a chair, bag of goodies, including my little clock drive motor and flashlight clock, notebook. Very important. Get a good solid notebook and keep track of it. And then just sit down and collect the data.
Okay.
I collect sky, adjust the sky brightness, then Uranus plus sky, then sky, and then subtract the sky from the Uranus plus sky to get the Uranus. And again, I talk about this process in my book. And then, of course,
Mhm.
periodically, I'll take a peek through, say, the finder scope to compare Uranus to nearby stars and write down a visual magnitude as well.
Okay, so you always use your photometer for magnitude estimates.
Yes, well, the photometer is very accurate.
Yeah.
With the human eye, it depends on who you talk to. I think you can get brightness measurements accurate to about zero point 0.1 to zero point 0.2 magnitudes.
Yeah.
I'd say probably zero point 0.2 to zero point 0.3, maybe. I take that back. But when you take an average, then it you can get down a little better than that.
Yeah, my eyes 20 years ago would do that, not today.
The trick is to get a lot of measurements,
Yeah.
then take an average. Just like my students, they get 40 to 50 grades in a semester. They don't get three.
Hmm.
Because, if you have a bad day on one of those, I don't think it's fair to the student.
Very
So,
good. Very good. So if people want to join and contribute to the Uranus section, what could they do?
okay. It depends what equipment they have and what skill level they're at. For the beginner, as I said, I would recommend getting visual magnitude estimates of Uranus, learn where the planet is, learn how to find it. And but for the more seasoned observer, who's got a camera and let's say a permanently mounted telescope, 10 to 12 inches or 14 maybe, collect some images, and or you can actually use your CCD camera to get photometric data.
Hmm.
VSO has been doing that for a while. But again, if you're going to do that, make sure you have an infrared blocking filter because, and of course, you that way your data is legitimate. I'm afraid I've seen data that is not good. And of course, the other thing I'm going to say, if you collect data, look at the professional literature. You need to do a literature search. See what the brightness is supposed to be.
Hmm.
For Uranus, if you get a brightness of in the V filter of seventh magnitude, there's something wrong because it's around 5.7
Okay.
magnitude. So,
All right. Well, Richard, is there anything else you'd like to share with our viewers today?
well, just I'm very excited about Uranus. What I'm going to do is I'm also going to measure Uranus in the near infrared light, the Johnson eye filter. I've been doing it in the ultraviolet filter, and I want to compare to what I did 20 years ago, and we're going to learn something about the North Polar Hood. You got to remember, the last time the North Polar Hood was as good as what we're seeing this year was way back in 1950.
Oh my.
Most of us were not even alive in 19.
No, we weren't, were we?
And so that's what's neat about Uranus and Neptune. My goodness, it's 165 years for one orbit.
Yeah.
So so I'm excited, and there's it's you can't be too young. That's one thing.
There you
All you need is a pair of binoculars and a good star map, and you can get that probably on the computer. Those young people are very tech savvy,
go.
and you can go at it just getting eyeball brightness measurements. I'll collect those,
Okay.
and but again, know what others are doing. That's one thing I don't really want to stress with people. Know what the professionals are doing. The British Astronomical Association, keep up with them, and I'd like to hear from you.
Great. Well, Richard, with that, I want to thank you for coming on the podcast today.
You're welcome, Tim.
All right. All right, well, that's going to wrap it up for this episode of Observer's Notebook Podcast. A big thank you to Richard Schmude for coming on today and giving us a good talk about the planet Uranus. Get out there, try to observe if you never have. It's not that hard to find, it really isn't. If you enjoyed this episode, please take a moment and give us a thumbs up. That really helps our algorithm in YouTube and brings more people to our channel. And if you really like the podcast, subscribe and share the podcast. New episodes of the Observer's Notebook come out on the 1st and 15th of every month. You can find us on iTunes as well as the ALPO YouTube channel. If you'd like to help support the podcast, you can do so through Patreon for as little as a few dollars a month. Up to $35 a month will receive benefits including 1 year membership to the ALPO and producer credits on the podcast. And with that, I'd like to expend special thanks to Steve Siedentop and Michael Moyer for their generous support of the Observer's Notebook. And as always, you can reach me directly by email at tim.robertson@alpo-astronomy.org. Thanks for joining us on the podcast today. You can join the Association of Lunar and Planetary Observers today. It's just this easy. You can become a valuable member of this International Lunar and Planetary Astronomy Organization, founded in 1947 by Walter H. Haas. It's based upon the structure of the British Astronomical Association. You can join various lunar and planetary observing sections, contribute to our massive archive of observations. You'll have access to our extensive lunar and planetary gallery of over 20,000 photos and observations of the sun, the moon, comets, meteors, and the planets. You'll receive our quarterly publication, the Journal of the Association of Lunar and Planetary Observers. You'll have the ability to join the ALPO training program, which will teach you the finer points of making planetary observations. You can attend our annual virtual conference, and you'll have access to the Observer's Notebook podcast. Membership begins at only $22 a year. The way to find us, just go to your Google and type in ALPO Astronomy, and you'll see this prompt come up. There's our association with our website, alpo-astronomy.org, and you'll come to our homepage. If you look at the top of the homepage, it says Join ALPO. Click on that, and you'll come to the sign-up screen. Gives you the information on the organization, and there's two ways to join. You can join by mail, where you will download a membership form, or you can pay online using PayPal. This is the PayPal processing page. You just fill out a few information lines, and then you're given the chance to click PayPal and join the association. Welcome to the ALPO.